Hello guys, welcome to my channel and let me introduce myself first. My name is Arnav Goel and I am currently in third year in Triple IT Sonipat doing BTech in CSE. Without any much further delays, let's start with the question. So the question is from CSES, the there is sum2 and what is given. So given is like we have given an array that consists of n integers. So our task is to count the number of subarrays whose sum is x. So what is subarray? First of all, let me introduce what is subarray. Subarray is like the contiguous part of that array. I think you didn't get it. Okay. So if we choose an index I of a subarray, let's say the index is 5, then the subarray should or must consist of its neighboring index. That is 5, then 6, then 7, then 8, or maybe 5, 6, 7, and 8. Not like if you take like 5, then you choose the element at index 9. Like not that like that. It will be a subsequence. I think you get it. If you not get it, what is subarray, then I will explain the question. So what is the input? So we have given two integers that is n and x. So the size of the array and target some x and n integers. So that is content of the array. And constraints are n is from 1 to 2 into 10 to the power 5. And x and contents of AI are from minus 10 to the power 9 to 10 to the power 9. Okay, so let me take the test cases. So, yeah, I will have to explain the subarray first. So, what is subarray? Subarray, you think it like this is an array, and inside this array, if I choose the first part, like I choose set 2, then if I have to grow my array, subarray, then I can choose only minus 1 and then 3. Like you can see the contiguousness, like contiguous, then 5, then minus 2. You like 2, then minus 1, then 3. You cannot choose like you choose 2, then you choose 5, then you might choose 2, minus 2. You will end up with subsequence. So it will be a subsequence, and this one is your subarray. I think you get it. I think you get now subarray, what is subarray? So how can we think, first of all, like how can we approach this question? Brute force. So first of all, it comes with a brute force. Like we move, we iterate from I equal to 0, like with two for loops. One of them is nested loop. That is choosing I equal to 0, then I iterate whole array and then check whose sum becomes equal to x. Then same with minus 1, then blah blah. Let me write it. Like we choose 2, then minus 1, that sums around to be 3, sorry, 1, and then like then 2, then minus 1, then 3, and that's for I equal to 0, and then for I equal to 1, that is 3, oh sorry, that is minus 1, then 3, then 5. Then that's how we will count our total sums overall. Then check is it equal to x, like for loop inside a for loop. I think you get what I'm saying. So it how much it would cost around, like time complexity, I mean. The time complexity will be order of n square. And is order of n square good for this problem? Like our code run? Will it give TLE or no? It will give TLE. Reason is that the constraints like n is around 2 into 10 to the power 5. 2 into 10 to the power 5. And n square will be around 4 into 10 to the power 10. And to successfully run the problem, to not get TLE, we have to end up our time complexity around 10 to the power 8. And this one is way much bigger than that. So we need to think in order of n, or maybe in order of n log n. Okay, so how we will think then? So one thing we should like, how what like there is a brute force approach. And most of the problems, if we think the brute force, if we then optimize it, will definitely give to the answer. So we have think the brute force. Now our main goal is like how can we decrease the time complexity? Like which one is repeating itself? That we need not to calculate it furthermore to reduce our time complexity. If we can find out which one is repeating, then our time complexity will be decreased. So here our test case. So if we think for I equal to 0, what we will end up like 2. The sum for this one is 2. Then 2 and minus 1. The sum goes for us around 1. Then 2 minus 1 and 3. 5 and 4. Then 2 plus 3 minus 1, that is 4. Like that. Up to the nth index. N minus 1 index. That is the last index you can say. That is the total sum around to 149 and then 7. We have find out. Then we move from minus 1, then we iterate the whole array. Can you like if we need to find out this sum, we are like we are moving again another for loop, but we already pre-compute this part. If we remove this part, we already pre-compute from I equal to 0 to I equal to 2. That is 2 minus 1 and 3. Like see this 2 minus 1 3, that sums around 4. If we remove the first index, that is 2, that is 0th index, that is 2, then the sum is actually 2. We get actually 2. And yes, the sum is 2. Okay, so we can remove this repetitive task. So we can just store it in our prefix sum. Like I mean that we can create a vector, and inside that vector, like data array, inside that array, uh, 2, then prefix sum, that is 2, that is then minus 1 becomes 1, then 2 minus 1 and 3 becomes 2, oh sorry 4, and so on. First of all, we will do now 2, 1, 4, 9, and so on. Now our main goal is what? Our main goal is that we need to find out the subarray, that subarray whose sum is equal to x. If we need to find out, if we need to find out the, if we need to find out, wait a second, if we need to, if we need to find out the sum of minus 1 and 3, we just subtract from 2. So that's why we have stored in the vector. Now what we will do? So now what we will do? Okay. So let me write first, then I will explain. Prefix of I is equal to, this is what it is saying. What like you think like what is what you have written? I didn't get it. I know. So if we like if we wanted to find out the sub array sum, like minus one and three, whose sum is two, then we just what we have done that is remove two. Then what if total we have to find out the sum of uh, index, that is let me write index 0, 1, 2, 3, and then 4. If I need to find out the sum of the subarray that whose index starts from 2 and ends up end at 3, that is 3 and 5, whose sum is 8, then what I will do? I will just do that is to remove, is to do like the prefix that we have stored in the vector, that is prefix of 3 minus prefix of 1. That will gives us 8. As you can see, 9 minus 8. Because this total sum we have find out, And we just if we just remove this part, that is 1, then we end up with this. So that's why I have just said prefix of j minus prefix of I is equal to x. So prefix of j, that is future prefix, like future prefix you can say like j, like greater than I index, should be must be equal to prefix of I plus x. So our main goal is to construct a prefix and then add plus x. If we can find any prefix, any index that is greater than I, whose prefix sum is equal to this, we will definitely say the answer. That will be our answer. I think you get it now. Okay, so let's move to the code part now. I will explain it into the in code part. So we just store it int n and x. Then it's a vector whose index we have chosen from whose size is n plus one, because I want it to be a one base index, not zeroth index. Like not storing from zero, I want it to store from first index. Then I will just take that those old content of array, and if we just let it more clearly. I think you will not get it. Vector of long I think prefix n plus. So we just create another prefix that vector and a map, a hash map. Why we have chosen an hash? Why we have chosen a map? Because we need to store how many of them, like prefix of I plus if we do x, then we need to find out how many of them whose prefix sum is this. If I have to introduce like if prefix of j is 8, of j is 8, and these frequencies are 3, that is three possible prefixes are like three possible of subarrays are like prefix are like whose sums prefix are 8, and there are three of them. Wait a second, let me explain it more clearly. Wait, why we choose a map, right? I will explain it through code. Okay, so we have chosen a map, and why we have chosen like you are thinking like why we have chosen MP of 0 equal to 1, like why 0, and then this. Since what we are doing, let me introduce again. I know maybe I cannot explain to the code part. I think so. So what we are doing is, wait a second, just a second, please. I am thinking like how can I explain it to you? Let me think it first, like how easily I can explain so you can get it. Okay. So first of all, let me tell you why we have chosen the map. Why we have chosen the map. Let us suppose that is 2, 1, 4, 9, 10, 7. Then again, maybe prefix sum is 8, then 7, then 11. So we just see that there are the 7 frequency is 2. So if x is equal to 6, if x is equal to 6, then 1 plus 6 is equal to 7. So there are two indexes so far whose sums equal to 7. That is prefix of I is 1 and prefix of j equal to 7, and prefix of I plus x is equal to this, and there are two. So we will say that there are two sub arrays that will gives us that will gives us that will follow what we are wanted to find out, the sub arrays. whose sum will be equal to 7. Sorry, whose sum will be equal to 6. That is this one and this one. Okay. So this is the way why we are choosing the frequency. Like we are choosing we are choosing maps to store the frequency of them. Okay, so we know about we have created the map part. Now why we are choosing MP of 0 equal to 1, and if we have chosen like if we have chosen then like why? Uh, Wait a second. It's getting hard for me to explain. Uh, Wait. As I already said, it's easy to do but hard to explain. So wait just a second. If you don't want to see it, then don't see it. There are much more editorials or videos that explain much way better than me. But if you can support, then support. If you wanted to see, then you can see it too. So we have created the map part. We know about why we are storing the map. And let me tell you why we are just doing this MP of 0 equal to 1. The reason behind this is simple and clear. Like this one. Okay, I put something new. Wait. Put something new. So 21497. If we find out the from the zeroth index, like if we find out from and we need to find out from like from zeroth index to the jth index, the subarray sum. That would be your prefix of jth index. If we wanted to find out the subarray of that, minus prefix of I equal to that cost around, let's suppose k, and if we just that is from here, that is 9 minus 2 is equal to 7. But if we wanted to go from the zeroth index to the jth index, that sums equal to 9, but it would give us 7. So we will just make up a zero, a temporary thing. Yes, it's because like if we want from the first index, from the zeroth index to the jth index, that sum should be maintained. That is continuous part. Uh, it, that is from this to this. So this whole part, this whole subarray, we need to find out. So that's why we need to introduce the zero, so that we can find out the actual part of that, actual part of that. Prefix of j. Wait. Let me introduce more. Like what is prefix of j minus prefix of I is telling us. Think prefix. Let j be your third index. That is the 9, and I be your zero index, and that's your value is equal to 2. So what is 9 minus 2 is saying? That is this part. That is this part. That is not include 0. Include first index, second index, third index. But if we wanted to if we wanted to also include zeroth index, then we can't find out. Reason behind that, we have to subtract from some that value, prefix of that value that contains 0, like that contains 0, so that we can find out actual value of prefix of j. That contains the contiguous part from zeroth index to the zth part. That's why we introduce zero. I think you now get it, or you, if not get it, then comment it out. I will try to explain it more clearly. So that's why I also introduce MP of 0 equal to 1 to store that it's a temporary thing, it's a temporary value, stored it as a frequency of 1. Now we are moving to a for loop. Then we calculate the prefix values, prefix sums of all, and then store the frequency of all of them. Then we calculate the answer. Then we initialize the answer, and then we then just move from like what I've already told you. We are now moving from zero to n. That is, we are including zero value to the vector, so that we can just take the take from zero to zero index to the zth index, the actual value of that subarray, the actual value of, of that subarray. Okay, so what we are doing is to add, like, if the current prefix, the current index I, the prefix value sum added with x, and then find it out in that map. That is how we can find, like, mp dot find and then that value. It will returns out an iterator. If we can find if that iterator is not equal to mp dot n, then that means we have find out the answer. Okay, so what is answer? Then answer will be first. Okay, so what is the edge case? The edge case is that if x equal to zero, if x equal to zero, what if x equal to zero? Then that prefix sum, that is 3 plus 0 equal to 3. So that what is doing there? It is pointing itself, and we can't do that. Since it, and we cannot do that. So what we will do is we just remove that part, that is ans plus it dot second, that is the frequency stored, and then remove that prefix value from there. That is the frequency. Sorry, let me explain it. Like, the prefix of I plus x equal to prefix of I. Let's suppose it happens. Let's suppose it happens. So that means the prefix that the prefix of I inside that map frequency is, let's suppose 4. Let's suppose 4. Then that value, that the current ith value also stored in the map too. So we cannot include that. So we just have to remove that part. That is equal to 3. That will make us aware. And then we will add into our answer. And then ns equal to that. If x equals, if this condition is not following, then we don't do anything. We don't need to do anything. That is subtracting minus 1. Then we just add. So after we have done this process, now we just remove that prefix r from there, so that we can seek for the future ones. Now we will print out answer. So that's it from my side, and I know you will not get it, but just comment it how I will try to explain it. So that's from my side. Bye.